You can listen my voice now. Can you hear me now?
Yeah, Surya, audible.
Yeah. You can also speak, I think.
Yeah, sir.
You can join now. Yes. I'm sharing here. Right. I hope you can hear me right. My voice is clear. You can follow the class now. Fine. You can hear me also, right? Now see the previous problem, this is the previous class I have done this problem. In the previous class I have done this one. Just verify this problem. This is the previous problem, f of x plus cos x by tan x, find f dash of x. Using quotient tool we have done this problem. I completed using quotient tool u by v square u into derivative of v minus v derivative of u. I have done this. Next one, find the derivative of I find d by dx of x power 5 minus cos x by sin x. After completing this, I will do miscellaneous exercise. This is x power 5 minus cos x by sin x. Sin x, right. So this is a problem here. You observe here, in this problem, we should use quotient rule. You know the quotient rule, d by dx of u by v square, v into derivative of u minus u derivative of v. Same thing you can consider this one, d by dx of x power 5 minus cos x by, you have taken sin x. Then you write sin x whole square, right? Sin x whole square. You can write sin x into d by dx of, when I have taken sin x into d by dx of x power 5 minus cos x minus x power 5 minus cos x into d by dx of sin x. Just quotient to d by dx of sin, this is cos x. Now you can see here, when I have written like this, I can write. So denominator sin square x. This will be sin x derivative of x power 5, 5x power 4, derivative of cos x minus sin x, it will be plus sin x, minus x power 5 minus cos x, derivative of sin x, it will be cos x. Now I can simplify this. This you can take the LCM now. Sin square x, take the sin x means sin square x. This will become multiply this. I can write 5x power 4 sin x plus sin square x. Again this is sin square x minus x power 5 cos x minus plus cos square x. But we know that sin square x plus cos square x is equal to 1. So we can write this is a sin square x plus cos square x is equal to 1. I can combine this and this, it will be 1. So you will get 1 minus x power 5 cos x, 1 minus x power 5 cos x plus 5x power 4 sin x by sin square x, by sin square x. Right, this we have done this, correct? So I have done the quotient rule here. I think is it clear? I understood this. Is it clear? I understood that. Right. So you can see here, when they are talking about this one, I can write this one. We can explain now. In this concept you see here, this is over now. After coming to the miscellaneous exercise, see in the miscellaneous exercise, starting miscellaneous exercise now. So I am talking about miscellaneous exercise. In miscellaneous exercise, the first problem we have done yesterday, remember? F of x equal to, that problem I have done that. So you see the first problem is f of x equal to minus x, that we have done. In miscellaneous exercise, the first problem I have done. F of x equal to minus x, we have done that. Correct. Now I will do the next problem. What will be the next problem they are given? F of x equal to a minus x whole power minus 1. In the first main, the problem they are given f of x equal to minus x whole power minus 1. By first, they are asking by first principle. They are asking by first principle. From first principle. From first principle. They are asking to use from first principle. When they are asking to use from first principle, see here, this one very simple problem. Try to understand, this is a problem is simple here. I can write f of x is equal to minus x whole power minus 1. Minus x whole power minus 1. This will be, I can write 1 by minus x. 1 by minus x. They are using first principle. But I can find derivative. You know that minus x whole power n. If you use that, the formula I can write minus 1 into minus x whole power, you can write minus 1 minus 1. This will be minus 1 by, you will get, if you write this one, it will come minus 1 into. Because this will be minus 1 by x, it will come 1 by x square it comes. Because if you write the derivative, I can write this one, I will explain this one when comparing this one. I got minus 1 by x, right? If you write minus 1 by x, this is nothing but minus x power minus 1. Correct? This will be minus x power minus 1, right? This is minus, this is you can see here what it meaning. I have written 1 by minus x. So minus x, I can write minus x whole power minus 1. When I have written like this, the derivative, if you consider, this is f of x, f of x means this is f of x. So f dash of x, without first principle I can write, this is x power, you can write x power minus 2, it comes 1 by x square. You know, minus of x power n into x power n minus 1. If you apply that, it will come minus 1 into minus 1, correct? Minus 1 into minus 1 x power minus 1 minus 1, it will become x power 1 by x square. Check that. This we have done using that formula. But they are asking by first principle. first principle means we know f dash x is equal to limit h tends to 0 f of x plus h minus f of x by h. Use the formula here when you are doing using first principle. So I can write limit h tends to 0 f of x plus h. Replace wherever x plus h minus 1 by x plus h. I can f of x minus 1 by x plus 1 by x into I can write 1 by h. This is h. Now limit h tends to 0. You take LCM x plus h into x. This will be minus x plus h into 1 by h. Correct? 1 by h. Now you can see this is x square. Now if you take this one, I can eliminate this one. Minus x plus x I can eliminate. Then you will get limit h tends to 0. After cancellation this one, I will get this one. Limit h tends to 0. You can get h by x plus h into x into h. So h will get cancelled. Apply the limit 1 by x plus 0 into x. It comes 1 by x square. So that means derivative of minus 1 by x is 1 by x square. Because we have done here using derivative of x power n into x power n minus 1, we got the same thing. Like that we can verify. So finally we got d by dx of minus 1 by x is equal to, this is d by dx of minus 1 by x is equal to 1 by x square. Remember this. Like this we have done this. Next one. When they are talking, another one. So again first principle only. Sin of x plus 1. I hope you understood this right. Any clarification you want, let me know. I can discuss with you. Is it clear? I understood this. If you have doubt, you can ask me. Is it clear? Any doubt you have? Is it clear? Fine? Yes. Now, I can discuss the next one. Sin of x plus 1. See that sin of x plus 1. The next problem is sin of x plus 1. So you take the function f of x is equal to sin of x plus 1 from first principle. From first principle. They are asking for first principle. We are going to using by first principle. You write formula f dash x is equal to limit h tends to 0 f of x plus h minus f of x by h. Write formula limit h tends to 0. I can write sin of x plus h plus 1 minus sin of x plus 1 by h. Apply sin c minus sin d. This is sin of right. Apply sin c minus sin d. If apply sin c minus sin d, limit h tends to 0. This is 1 by h. I can write sin c minus sin d. 2 cos c plus d by 2. You will get x plus h plus 1 plus x plus h by 2. And sin c minus d by 2. X plus h, because they are talking about c minus d by 2. When they are talking c minus d by 2, I can write sin c 2 cos c plus d by 2 sin c minus d by 2. C is here x plus h plus 1 minus x minus 1, because c plus d c minus d by 2. I can close the bracket, right? This will come limit h tends to 0 1 by h. This one 2 cos of x plus x 2x plus 2h plus 1 by 2. It comes right. You got x plus h plus 1 plus x. This is x plus 1, right? You will get 2x plus h plus, be careful, h plus 2. This one it comes. And this one here, plus x minus x cancel, plus 1 minus 1, sin h by 2 it comes. Sin h by 2. Like this it comes, right? But we know that here, what can I do here? When you got like this, I can write limit this h tends to 0, sin h by 2. I can write sin 1 by 2 into h by h into limit h tends to 0. This also h tends to 0. I can write 2 cos of, I get this one. You can see here, you can apply, this is a 2x plus h plus 2 by 2. If I apply the limit, we know this value. In the previous class we have discussed, this is sin n theta by theta, where theta it should be in terms of radians. Limit theta tends to 0, sin n theta by theta is n. This value will be equal to 1 by 2. Again, at 2 into apply the limit, cos of, you will get 2x plus 0 plus 2 by 2. 2x plus 0, in the place of h, you write the place of h 0. Right. 2x plus, correct. You can write 2x plus 0 plus 2 by 2. So I can write this is 2 to cancel. Here it will come cos of 2x plus 2 by 2, cos of x plus 1. So this is your answer. The derivative of sin of x plus 1 is cos of x plus 1. The derivative of sin of x plus 1 cos of x plus 1. Just go through that. So this expression, sin of x plus, so write the first principle formula. Replace that f of x plus h and f of x. Apply sin c minus sin d. Then you simplify. Then you write sin 1 by 2 h by h. This will be equal to 1 by 2. 2 into apply the limit. It will become cos of x plus 1. Cos of x plus 1. So this way I have explained this. Now I will do the next one. I think it's clear, right? You understood that, right? I hope it's clear. Yeah. Yes, it's clear, right? Now we can write this. I can write this all right. Now you can see here. Now when you're coming to this, the next one, I can explain the next problem, right? All right. Now coming to this, I can go to the next one here. All right. So the next problem, when they are given this one, cos of x plus 1. Next one, cos of x minus pi by 8. The function you take, f of x equal to cos of x minus pi by 8. Cos of x minus pi by 8. So these are again first principle. Cos of x minus pi by 8 from first principle. They are asking using from first principle. They are asking using from first principle, you should do that. Using first principle, they are asking here. Right, now you can see that. When I have written like this, then you can observe here. So cos of x from first principle, then again you write f dash x equal to limit x tends to 0, f of x plus h minus f of x by h. Then limit h tends to 0. What is f of x plus h? Cos of x plus h minus pi by 8 minus cos of x minus pi by 8 by h. Right? It will come like this. Cos of x minus pi by 8 by h. When they are given like this, apply again cos c minus cos d. Just observe cos, what is cos c minus cos d? Limit h tends to 0. When you are applying cos c minus cos d, what is cos c minus cos d? Minus 2 sin c plus d by 2, c plus d, x plus h minus pi by 8, x plus h minus pi by 8, plus x minus pi by 8 by 2 into sin c minus d by 2. you will get x plus h minus pi by 8 minus pi by 8 minus x plus pi by 8 by 2. You can write like this, right? Minus 2 sine c plus d by 2 sine c minus d by 2. You will get like this, right? So limit h tends to 0, we get like this. Correct. This is x minus x plus pi by 8. So here I can write plus x minus x cancel, minus plus pi by 8, h by 2 it comes. Whole by h is here, right? By h is here. I can by h. Now you can write the product of two limits. I can write this one. Limit you can see now. What can I write here? Limit h tends to 0. Limit h tends to 0. Minus 2 into this value you can write. You can see here x plus x 2x sine of 2x. I can write minus pi by 8 minus pi by 8. It will be 2 into minus pi by 8 minus pi by 4. And this one plus h by 2 will be there. By 2 will be there. And this one sine of h by 2. So you will get 1 by 2 into h. This h I can write by h. Applying the limit. If you want, you can write two separate limits here. You can write this one. I can write limit of this one. Again, I can write this one also. Limit h tends to 0. Limit h tends to 0. Sine, I can write sine this one. You will get h by 2 means 1 by 2 into h by h. So this will be 1 by 2. If I apply the limit here, minus 2 sine, apply the limit in the place of h 0, 2x minus pi by 4 by 2. It will come x minus pi by 8. This will become 1 by 2. 2 will get cancelled. Our answer is minus sine of x minus pi by 8. So that will be the derivative of cos of x minus pi by 8. This is the derivative of cos of x minus pi by 8. By using first principle. So I have completed the first main. If you have doubt, you can ask me. If you have any doubt, you can ask me. Right. If you have doubt, you can ask me. I can explain to you. Is it clear? You have doubt, you can ask me. I can explain to you. Right. Is clear? Then fine. Now I will do now. You can see this. The next one. Right. They are asking now define derivatives of d by dx of. Only of the first principle we can do now. Find the derivative of x plus a. Find the derivative of x where a is constant. Second main, the first problem. I am doing the second main, the first problem. So second main, the problem is second only. The second, they are asking second problem. What is the d by dx of x plus a? What is the derivative d by dx of x plus a where a is constant? D by dx of x plus where a is constant. That where a is derivative of x is 1, constant 0, it comes 1. They need us by using first principle. Directly I can do this. X plus a, derivative of x is 1. I can do like this. Right. Next one. They are asking third problem. Find the derivative of px plus q into r by x plus s, where PQR and S are fixed non-zero constants. Where P, Q, R, S are fixed non-zero constants. They are asking d by dx of this product rule. Two factors are here. They are asking to find product rule. So here they are asking to find product rule, right? I am going to use product rule here. When using product rule UV, what is the product rule? First into derivative of second plus second derivative of first. So I can write first into d by dx of second. This is r by r into x power minus 1 I can write plus s plus second into r by x plus s into d by dx of I can write px plus q. This is px plus q I can write px plus q, d by dx of px plus q. Product rule. When I have written this, I can write px plus q into, right, px derivative of this one, you can think px derivative of this one. When I have written px plus q derivative of this r into x power minus 1, minus 1 into x power minus 1, like derivative of x power n into x power n minus 1, constant is 0, plus r by x plus s into, here derivative of x is 1, constant is 0, q will be 0. You will get px plus q into, I can write this one, minus r by x power minus 2 minus r by x square it comes, minus r by x square, minus r by x square, plus this one p into, this will be p, you will get pr by x plus it comes ps. Right. You can simplify if you want. You can simplify here by this one. If you multiply this minus pr by x, it comes minus qr by x square plus pr by x plus ps. So then you can see here I can eliminate these two. Correct. Now your answer will be ps minus qr by x square. That will be x square. That will be your answer, right? You get that answer. Final answer will be that one it comes. QR by x square. Correct? This is a simple product rule. Use the concept of the formula, then you can do this. Is easy product rule. Now I am going to do the next one. Find the derivative of ax plus b cx plus d whole square. So what I will do now, when they are asking to find the derivative of, see here, they are asking d by dx of ax plus b into cx plus d whole square. Cx plus d whole square. They are asking like this. So generally the people, they will expand this, they will do. That way also you can do. But even I will tell you one chain rule also here. Easy to solve the problems. Sometime they may ask any other powers also we can do easily. I will tell you. Whole square means, okay, whole square, whole cube we can expand. If it's bigger number, how to do that? That also I will explain. When I have taken like this, use product rule. Ax plus b into d by dx of, you can write d by dx, a square of this a plus b whole square. This will be c square 2c dx plus d square plus cx plus d whole square into d by dx of ax plus b. I have written like this. So this is the simple concept I have written like this. D by dx of ax plus b. Ax plus b. Now I can consider here, when I have taken this, alright, ax plus b. So I will write here ax plus b into the derivatives. I can simplify ax plus b into this one derivative, c squared x square derivative, c square into 2x, 2cd derivative of x is 1, constant 0, plus cx plus d whole square, derivative of a into 1, constant 0. Right, this will become ax plus b into, I can get this one, 2c square x 2cd plus cx plus d whole square into a. Cx plus d whole square into a. Because we can simplify this. A into cx plus d whole square. 2c into. This one I can stop here. Even I can take it only 2c common here. If we take 2c common, we'll get 2c. I can simplify. I can stop like this. Even I can simplify. If we take 2c common here, ax plus b into, I can take 2c common here. This will become cx plus d. Because this is common here. I have taken cx plus d. This is common. Cx plus dd. 2c into. This 2c I can write here. 2c into ax plus b into cx plus d plus cx plus d whole square into a. Like this. This will be our required answer. Product rule. Cx plus d whole square. Then cx plus d whole square. I have done like this, right? I hope you understood this, right? Is clear? I understood this. Right. I hope it's clear, right? Now, after this, I will explain the next problem. So here, before doing the next problem, I will tell you the concept of suppose ax plus b whole power any number. That I will tell you now. The concept of ax plus b whole power any number I will tell you now. See that problem you can see now. For example, so sometimes we have one of the problem is there. I think in the problem we have ax plus b whole power and also problem is there. Okay. Anyway, in coming session I can discuss about that. See the next one. Find the derivative of d by dx of ax plus b by cx plus d, where a, b, c, d are fixed non-zero constants. Where a, b, c, d are fixed non-zero constants. This is u by v. U by v should use quotient rule. U by v. When they are asking derivative of u by v, v square, v into u dash, u into v dash. Correct. You write cx plus d whole square. But you can write cx plus d into derivative of this one I can write d by dx of ax plus b minus ax plus b into d by dx of I can write cx plus d. This is the quotient rule. This is with respect to dx. D by dx of. Right. Correct. Do d by dx of cx plus d. Now, we can simplify this. Now you can write this one. Denominator will be cx plus d whole square. Cx plus d whole square. You can write cx plus d into derivative of ax plus b. A into 1 constant to 0 minus of ax plus b. Derivative of cx plus d. C into 1 constant to 0. We can write this. Now you can simplify. So just you can see now this you multiply acx plus ad, this one minus you will get acx minus bc by cx plus d whole square. Now you can observe here, if you observe this one, acx it will get cancelled here. This will be ad minus bc by cx plus d whole square. Cx plus d whole square. So I have used the quotient rule. I have done this. But the most important point here, remember this as a formula also they will remember. I will tell an example also. For example, they are given remember as a formula also. D by dx of whenever they are given ax plus b by cx plus d. Always when they are given like this, remember this is denominator cx plus d whole square. You see, let it in this formula ax plus b cx plus d. Then you do cross multiplication a into d. ad minus b into c. You multiply these two and these two coefficients. I will repeat here. When they are given here ax plus b by cx plus d. Cx plus this is x only. ax plus b by cx plus d when they are given. Just you can think, you take this a and d, ad, this is ad, I can write here, ad minus, you take b and c, bc by cx plus d whole square, that we can write, ad minus bc by cx plus d whole square. For example, I will tell you one problem. So to do quickly this one, actually in the CBSE or board exam don't use like this. For CET purpose or any entrance exam you can use this. For example, d by dx of the given minus 2x plus 3 by the given minus 2x plus 3 by the given x, correct, minus 2x plus 3 by the given 2 minus 2 plus x the given. But you should rearrange this, d by dx of minus 2x plus 3 by x plus 2, because like this, not 2 plus a, right, x plus 2, because I should get ax plus b cx plus d form. Then you can compare with this. If we compare with this, I can write your answer, denominator whole square, x plus 2 whole square, x plus 2 whole square, right? Thus you can compare x plus 2 whole square, x plus 2 whole square. Now a means minus 2 into 2, minus 4, minus b into c. So 3 into 1, it will be 3. Your answer is minus 7 by x plus 2 whole square. Like this we can do. That is the reason you can use this concept to do very quickly. For CET point, any entrance exam point of view, we can use this. Otherwise, you should do quotient rule to solve this problem. Right. Find the derivative of the next one. Find the derivative of, see that one, find the derivative of, right, the derivative of right. When I am doing this one, I can write, find the derivative of that means d by dx of 1 plus 1 by x, d by dx of 1 plus 1 by x by 1 minus 1 by x, 1 minus 1 by x. When I have taken this one, you can observe this one, I can write d by dx of, you can simplify x plus 1 by x by x minus 1 by x. So this will become d by dx of x plus 1 by x into x by x minus 1. Then I can eliminate this x and x. It will be d by dx of x plus 1 by x minus 1. So I will get now d by dx of x plus 1 by x minus 1. So like previous method, I can verify your answer. In the previous, if we do previous method, 1 into minus 1, minus 1, minus 1 by x minus 1 whole square, it will be minus 2 by x minus 1 whole square. If we do in the previous method, this is the answer. But if we do quotient rule, here we should use quotient rule. If we use quotient rule here, it will come now x minus 1 whole square. You write x minus 1 into d by dx of x plus 1 minus x plus 1 into d by dx of x minus 1. You take, I am using quotient rule here, d by dx of x minus 1. Right, d by dx of x minus 1. Then when I have taken this d by dx of this is x minus 1. Right, the denominator same thing, x minus 1 whole square, x minus 1 into derivative of x plus 1 will be 1 plus 0 minus of x plus 1, derivative of x minus 1, 1 minus 0. Then if we simplify this, check here, you will get this will be x minus 1 minus x minus 1 by x minus 1 whole square. Now here this plus x minus will get cancelled, result will be minus 2 by x minus 1 whole square. But that is the required answer, right? Minus 2 by x minus 1 whole square. So that is the required answer. Right. Now I'm going to do another one. Find the derivative of 1 by ax square plus bx plus c. Find the derivative of, that means d by dx of 1 by ax square plus bx plus c, where a, b, c are fixed non-zero constants. Where a, b, c are fixed non-zero constants. A, B, C are fixed non-zero constants. So again I can use quotient rule. 1 by ax square plus bx plus c. I can use quotient rule to solve this problem. If I use quotient rule again, you see here I can write ax square plus bx plus c whole square I can write. Then ax square plus bx plus c into, I can write d by dx of 1. D by dx of 1 minus, I can write a, because 1 into, because I can express like this I can write 1 into, so d by dx of ax square plus bx plus I can write. I am using quotient v square, v into d by dx of u minus u into d by dx of ax square plus bx plus c, ax square plus bx plus c. Now, when I have taken this one denominator, ax square plus bx plus c whole square, then you will get ax square plus bx plus c into derivative of 1, 0, minus 1 into derivative of a into x square is 2x, right? Bx means b into 1, 2x plus b into 1 constant 0, the derivative of constant 0. Correct? We can simplify now. If I say this will be 0, you will get this one, you will get, because a into 2x, 2ax, it becomes 2ax plus b by ax square plus bx plus c whole square. So that is the required answer. We get like this. Just you can verify that. You will get the required answer like that. Right. That will be your required answer. Alright, now you can see now, when they are given like this, right, is it clear, right? See the next problem, 2ax plus b by ax square plus bx plus c whole square. I hope you understood this, right? Is clear? You got the point, you understood, is it clear? Right. Then, when I look into this, the next one, find the derivative of d by dx of ax plus b by find the derivative of ax plus b by find the derivative of ax plus b by px square plus qx, px square plus qx plus r. This is ax plus b by, where a, b, p, q, r are fixed non-zero constants. Where a, b, p, q are fixed non-zero constants. Here also do it quotient rule. Do the only quotient rule here. So we should do the quotient rule. I can write again px square plus qx plus r whole square. Then px square plus qx plus r into d by dx of ax plus b minus, I can write ax plus b into d by dx of px square plus qx plus r. I am using quotient rule. V square, v into derivative of u minus u into derivative of v. Right. Now the denominator will be px square plus qx plus r whole square. No need to expand the denominator. Leave it like this only. We can write px square plus qx plus r into derivative of a into 1 constant 0. This will be a minus a plus ax plus b into derivative of px square. You can write 2px by practice x square 2x 2px plus q into 1 q constant 0. Because already you practiced this. This is qx q into 1 or 0. X square is 2x, so 2px. Now I can multiply this, right? If I multiply, the final answer it comes now. I can eliminate, I can simplify. So which is equal, I can write apx square. Just you multiply this, you will get apx square. This is aqx plus ar. If you multiply this one, I can also multiply the entire expression. I can multiply. This is minus 2apx square. If I multiply this, minus aqx minus this will be 2bpx and this one minus bq by denominator it comes. Denominator will be px square plus qx plus r, px square plus qx plus r whole square. Now you can see here, I can eliminate aqx and aqs I can eliminate. Any other terms I can eliminate. You can see that the terms only, any other terms I can eliminate. This one will get minus apx square minus 2apx square. Same thing, this minus apx square it comes. If I simplify, this is apx square. This is also minus 2apx square, right? So then from this I can write this is minus apx square and this will come minus 2bpx plus ar minus bq by px square plus qx plus r whole square. Px square plus qx plus r, this is qx whole square. So this will be the required answer, right? That is the required answer. Just using quotient rule. Just applying quotient rule, we can do this. That will be the required answer. Right. Now I am doing this one. See that, find the derivative of px cube. They are asking again d by dx of. So d by dx of px square plus qx plus r by ax plus b, where p, q, r, a and b are fixed non-zero constants. This is px square plus qx plus r by ax plus b, where p, q, r, a and b are non-zero constants. A and b are non-zero constants. Again, I can use quotient rule here. Yeah, I am going to use quotient rule here. Just observe the quotient rule. When I am using the quotient rule here, next, if I apply quotient rule, same thing, apply the quotient rule, I will get now, the denominator will be ax plus b whole square, ax plus b into, correct, ax plus b into, you can write this is the quotient rule, ax plus b into d by dx of, I can write px square plus qx plus r, you can write minus, I can write ax plus b into derivative I can receive. I have written this one. Already I have written this step, right? U by v square, v into derivative of u minus u into px square plus qx plus r into d by dx of ax plus b. This is a quotient rule. Now when I am doing this quotient rule, you can see here, I will get same thing. I can express this one. Denominator will be same. I can write denominator will be same. Right? Ax plus b whole square. Now ax plus b into derivative of this part. You can write px square, x square 2x, 2px, and this will be q into 1q, constant 0. I can write this one px square plus qx plus a derivative of ax plus b, a into 1 constant 0. This will be a into 1 constant 0. Then I can simplify this. We can simplify which are the possible. I can eliminate this one. So we can simplify the term. I can write this will be, you can see, I got this one 2px plus q. This is x only, 2px plus q. I can multiply this, both I can multiply this one. This will be 2apx square. This is 2px. This will be 2apx square multiplying this. This will be aqx. This will be 2bpx multiplying all this will 2bpx plus bq. You will get not bq. It will be bq minus apx square minus aqx minus ar. I can write this one minus ar. The last term is minus ar by ax plus b whole square. Ax plus b whole square. Now you can see this is a 2apx square. See a 2ap, this is 2apx square here. Here minus apx square. I can simplify this. Correct? So aqx I can strike out this one, right? Other terms I can't eliminate here. When I have taken this one, 2apx square minus apx square, it will come apx square. So your answer will be apx square plus, this is minus apx square because plus, yes correct, plus apx square only, apx square plus 2bpx plus bq minus ar by, it will come ax plus b whole square. Should be careful when the term, sometime you made a mistake, you should be careful. Right. You can see the term, the given here, there's a problem pxq plus ax square, correct. You have taken the terms right. All the terms you can simplify this. So just verify the answer again. If you have any doubt, you can verify the answer here. Right. Because this is the way you can do this problem, right? Quotient rule you have done here. We are using quotient rule. So that will be the required answer. Using quotient rule. Right. Next one. When I am doing the next one, so the next problem I have, find the derivative of, so one or two problems with that I will complete now. Find the derivative of a by x power 4, d by dx of, they are saying d by dx of a by x to the power of 4 minus b by x square minus b by x square plus cos x plus cos, this is x power 4. X power 4, this is a by x power b by x square plus cos x. Here where a and b are constants. A and b are constants. So when they are doing this problem, I can write d by, we'll rearrange this one. D by dx of a into x power minus 4 we can write. Our convenient we can write a into x power minus 4, correct, minus b into x power minus 2 cos x I can write, correct. This one will be a into x power minus 4. You know d by dx of x power n. Use d x power n. We know the n into x power n minus 1. I can use this one here. You will get a into minus 4 into x power minus 4 minus 1, correct. Minus 1 minus b into minus 2 into x power minus 2 minus 1. Derivative of cos x we know minus sin x. So this will become now minus 4a x power minus 5 by x power 5. This is plus 2b by x power minus 3. It will be x cube. So minus cos x. So that will be your answer, minus cos x. Because it takes one more session to complete our entire miscellaneous exercise. The simple problem is that one more problem. With that I will stop today. Right. It takes another 1 or 2 minutes. Again, the next problem I can do this d by dx of 4 root x minus 2. D by dx of 4 root x minus 2. When they are asking this one, I can write d by dx of, correct, d by dx of 4 into x power 1 by 2 minus 2. But we know that 4 into x power n formula, 1 by 2 into x power 1 by 2 minus 1 constant is 0. I can write constant is 0. Then this will become 2 into x power minus 1 by 2. It will become 2 by x power 1 by 2. That this is the required answer. 2 by x power 1 by 2. That will be the required answer. Almost we have completed almost around 11 problems in the miscellaneous exercise. The continuation of miscellaneous exercise I can do in the next session. So with this I completed this. So I can continue in the next session about this one. I will continue this. I hope you understood this. I continued this. Yeah, is it clear? I understood this. Fine then. Come back to class. Okay, fine.